This problem is number 4 on the free response practice, and it is a car is traveling with an acceleration of -2 meters per second. Its initial position is 0 meters, and it starts at a velocity of 12 meters per second. Draw a quantitative velocity graph. Also draw a position graph and motion map with correct initial and final points. So we're just going to write down some of the givens that were given here. And let me put my phone on a stand. All right, so our acceleration is -2 meters per second, which means that this negative tells us that it's slowing down. Okay. And then this velocity, that means that's our initial velocity. Our initial velocity is 12 meters per second. All right, so then coming over here, they give us our initial velocity of 12 meters per second. And it's going to be -2 meters per second for every second. So that means for every second, we're going to lose 2 meters per second. So 12 minus 2 is going to be 10. And we just keep losing 2 meters per second every second. And so lastly, at 6 seconds, we are left with the object at rest, or it's not moving. Okay. So coming over to the velocity time graph, we're going to go ahead and label these. And so since I know that the highest I need to go is 12, we'll just go by, let's see, we'll just go by 4s. Okay, so 12 meters per second is our initial, and we end at 6, and then it just goes down 2 every second. So we end up with a line that looks like this. To calculate the displacement, we're going to calculate the displacement, which is the area underneath the graph. So we have 1/2 the change in velocity times change in time, which is 1/2 of 12 minus 0 times time, which is 6. So we have 1/2 of 12 times 6, which is 1/2 of 72, which is 36 meters. Okay, so we're going to come around here, and we can read from the problem that has an initial position. So initial position of 0 meters. That means here our initial position is going to be 0 meters. And at 6 seconds, it's going to be 36 meters, because that is our change. Our delta x was 36 meters. So we're going to just add 36 to our initial, and we get our final. And we're going to also go by 6s here. 6, 12, 18, 24, 30, 36. Okay, and we're just going to go with the general shape. It's not totally accurate, but this is going to be sufficient for you. All right, and then for our motion map looks like it is slowing down. Okay. Then we're going to explain in a sentence what it means for the car to have an acceleration of -2 meters per second. Sorry about that. That was some visitors who came in. So explain a sentence what it means for the car to have an acceleration of -2 meters per second. So that means for every 1 second, the car decreases its speed by 2 meters per second. Okay, so that negative sign means it's decreasing its speed, and then the 2 meters per second is by how much it's decreasing. All right, and then how fast is the car traveling after 4 seconds? So we're going to look at our acceleration is equal to our change in velocity over time. Our time is going to be 4 seconds, and our acceleration was negative 2 meters per second is equal to, this is what we're looking for, and at 4 seconds. So we're going to multiply by 4 seconds on both sides. We have 4 times negative 8. We have negative 8 meters per second. So then that just means that it's decreasing speed. So that means it matches our graph that it's decreasing speed, or it's going, it has a negative acceleration, which means it's slowing down, and it will be at 8 meters per second. So that will be our change in velocity. Are the forces acting on this car balanced or unbalanced? And we know that it is going to be unbalanced because acceleration does not equal 0 meters per second. And that means that it is balanced if it does equal 0 meters per second. But since our acceleration is equal to negative 2 meters per second, that tells us that it is unbalanced. Okay? The total displacement of the car after 6 seconds. So we know that we're going to be using the triangle because of the shape of our graph. So the change in velocity times time, we have 1/2 our change in velocity. We started off with 12 meters per second. We finished off with 0 meters per second, and it took us 6 seconds to do so. So 1/2 of 12 meters per second times 6 seconds is equal to 36 meters. All right, and for our proportional reasoning. So now this is our B acceleration. Our old acceleration was negative 2 meters per second, and it became negative 1 meters per second. So then that means it decreased by 1/2. But it still underwent the same change in velocity, so this one doesn't change. In order for this to be true, 1/2 is equal to 1 over 2, so it would take twice as long. Since this was our last one to fill out, we are going to put that in our variable spot. All right, and so our coefficient of 2, our original change in time was 6 seconds, so our new value is going to be 12 seconds. All right, and so our sentence that describes the change is going to say, let's see here. Our sentence that's going to describe the change is, sorry, let me try and get a good angle. Okay. For the car to reduce its acceleration by 1/2, it must double its time to maintain the same velocity. Okay, and that is it.